Alright, so let's work on some more examples. Assuming I did get my thermometer in and I haven't unboxed it yet, assuming I get it all working, we'll go in the lab and try doing this. So let's say that we have 50 grams of ice that's at negative 10 degrees Celsius. And we dropped it into a beaker containing 500 grams of water that's at 80 degrees Celsius, almost boiling. After the ice melts, and assuming no heat is lost to the environment, what temperature will the beaker of water be at? So our equation is heat gained is equal to negative heat lost. So in a system, we have, so heat always transfers to something hot to something cold. So something is going to be, so the colder object is going to be gaining heat, while the hotter object is going to be losing heat. So on this side of the equation, we're going to have the water, the 500 grams of water that's at 80 degrees Celsius, and on this side we're going to have the ice melting. The ice melting is going to gain some heat. This is where I like drawing this. So down here, we have negative 10 degrees Celsius ice. This ice is going to gain some heat. It's going to move up until it reaches 0 degrees Celsius. And it's going to melt. And then there, it's going to continue heating as a water. So here it's solid. From here, it's going to be a liquid after it melts. And it's going to reach some final temperature. The water, however, is going to begin at 80 degrees Celsius, and it's going to move down until it reaches some final temperature. Where this line is, you have to guess. Do you think if you put some ice into into some water, do you think it would freeze all of it? So almost always you can guess correctly that this is above the 0 degree Celsius line, right? It doesn't matter where it's at, as long as you have it in the correct. You would assume the ice is going to melt and instead of the water freezing. You can have something else occur. Let's say that we have some ice that has been chilled to negative 300 degrees Fahrenheit. Some really super cold ice. In which case, if you were to pour some water on it, do you think the ice will melt or the water will freeze? Water would freeze because the ice is super cold. However, if this is not very cold and we only got 50 grams of it, well, we got 500 grams of nearly boiling hot water. So you have to make a guess at where this final temperature will be. And it's usually common sense to assume that ice in this scenario is going to melt. Let's reverse that and say that we have a giant big iceberg in Antarctica. If you were to take boiling hot water and pour it on an iceberg, you would expect that after a lot of time has gone by, the iceberg isn't going to melt, the boiling hot water is going to eventually freeze. Because there's a whole lot more ice than there is boiling hot water. So in that case, the final temperature would be going from boiling hot water down to freezing, and your final temperature will be down here. Where you draw this line takes some intuition. In almost all cases, I'm not going to do anything super tricky. It should be obvious. Put ice in a container of water, the ice is going to melt. So we're going to have the ice gaining energy until it reaches this final temperature. So it's first going to, so on this side of the equation, or gains heat side, it needs to go from negative 10 degrees Celsius ice to 0 degrees Celsius ice. I will also say that H of F of water is 334 joules per gram, and the CP of ice is 2.06 joules per gram degree Celsius. So to go from negative 10 degrees Celsius ice to 0 degrees Celsius ice, we'd use our heat is equal to mass times the heat of fusion. So 50 grams times 334 joules per gram, and we get 16,700 joules of heat. From here, we're going to go from 0 degrees Celsius ice to, and I realize I did this wrong. I'm trying to work ahead. Is this the correct equation to use? Which is the correct equation to use? Temperature change. I was too busy trying to write these values down. I wrote that one first, so I used it first. Sorry about that. So, on the gains heat side, we're going from negative 10 degrees Celsius ice to 0 degrees Celsius ice. This is a change in temperature. So we use the change in temperature equation. This is also solid to solid. So 50 grams times the change in temperature, 0 minus negative 10, is positive 10. And our CP is, for ice, is 2.06 joules per gram degree Celsius. A hint on how I discovered my own error is usually you're only going to have large numbers during phase changes. Not always, but general rule of case, the phase change takes a lot of energy. Next, we're going to go from, so we're going from negative 10 to, cross this out. So we're going from negative 10 to 0, and now we're going to do the melting phase. So 0 degrees Celsius ice to 0 degrees Celsius water. This would be your melting. Now we use this equation. Mass times heat of fusion. So our mass is 50 grams. Our heat of fusion is 334 joules per gram. And now we get the 16,700. Note that even though I made the error, I just had the wrong title up here. The last thing it's going to do is go from 0 degrees Celsius water to some final temperature water. And this is what we're trying to figure out. What is the final temperature? So this is a change in temperature, so we use the change in temperature formula. So the mass of the ice cube originally was 50 grams. It's now 50 grams of water. Delta T is equal to final temperature minus initial temperature. And the CP of liquid water is 4.184 joules per gram degree Celsius. I can go ahead and work this out and simplify. So that's 50 grams. I'm just going to leave off the units right now. I'll keep them in. So TF minus 0 is just TF. $50 times 4. Again, if we have multiplication, so this times this times this, it doesn't matter what order we do multiplication in. So 50 grams times 4.184 joules per gram degree Celsius. Well, the grams are going to disappear. And so we get with 209.2 joules per degree Celsius times TF. And this, all of this is dealing with the ice cube. Let me go back up here. It gains heat. This is ice cube. This is the 50 gram ice cube. So this is all the heat is going to gain until it reaches some final temperature. It's first going to heat up to the melting point and begin melting. After it reaches the melting point, it will actually start melting. And then after it's completely melted, it is going to warm up. And it's now water, and that little portion of water is going to warm up until it reaches some final temperature. Now let's look at it from the beaker of water. So the beaker of water is going to lose heat. This is the beaker of water. So it is going to be going from 80 degrees Celsius water. So looking at the little picture, it's going from 80 down to the final temperature directly. So we use Q is equal to the mass. The mass of it was 500 grams. Let me write above this. M delta T CP. So the delta T is final minus initial. Initial is 80 degrees. The CP of liquid water is 4.184 joules per gram Celsius. I can go ahead and boil this out. Probably best to do it without units. I know that the units are going to match the units from the previous side, so they'll be in the same structure. Let me temporarily remove units. So that's 500 times TF minus 80 times 4.184. So 500 times TF is 500 TF. 500 times negative 80 is negative 40,000. So we subtract 40,000. And everything is being multiplied by 4.184. We then do the same thing. 4.184 times 500 TF and that's 2092 TF, and then 4.184 times negative 40,000 be minus 167,360. I know this number is, so I know Q is in joules, so this would be joules. Let me write it down here. I know that this unit should be in joules per degree Celsius. You really don't have to keep units in if you don't want to, as long as you put units on the final answer. But now we got our right hand side and our left hand side. Yes, this is a lot of math. So our equation is Q gained is equal to negative Q lost. So all of this is our Q gained. All of this is our Q lost. So let's work it out. So we have this plus this plus this. So 1,030 joules plus 16,700 joules plus 209.2 joules per degree Celsius times TF, and it's equal to negative 292 joules per degree Celsius times TF minus 167,360 joules. And now we have our final equation set up. Do some algebra to solve for TF. Let's combine like terms. This and this can be added together. So 17,738 joules. We'll leave off units. The negative, we can distribute it in. So minus, again, this negative will distribute to here and to here. We FOIL it. Now we combine TF. So TFs are being subtracted on this side. We can add it to this side. We can remove it from this side by adding it over here. And we can remove this by subtracting it over here, subtracting it from both sides. So in effect, we're subtracting it from both sides, canceling that out, and we're adding this to both sides. So add TF to both sides, the 2009 2TF to both sides. It cancels it out on this side and subtract 17,000 on both sides to cancel it out and move it over. So adding those up is 2301.2. Now we divide by 2301.2 on both sides. And we get a final temperature of 65.01912 degrees Celsius. Do y'all think y'all can do this? It's just setting up the algebra expression. It's just doing a lot of algebra. We have on the left hand side our heat gained. We just add it up like usual. For temperature changes, we use this equation. So going from -10 to 0. For phase changes, we use something like this. Plug in the correct value. And for another temperature change, we have this. We have an unknown variable, final temperature. And then the total heat gained is just the sum of all three. So we just sum all three up. And we do the same thing for the other side, the heat loss for the ice cube, or for the beaker. And we get a final value, and we need to negate the total heat lost. And then we solve for it using algebra. If you want to be super quick on doing this, how I personally solve these problems is I do everything at once. So let's go back to the original problem. So original problem, Q gained. I would know that I need. I would just begin writing it out. I'd start with this for the ice cube melting from here to here. In which case I'd write my equation. 50 change in temperature. I added 10 degrees Celsius, go from -10 to that. For ice, it's 2.06. Then I add the melting phase. Melting phase would be mass 50 times heat of fusion, 334. And then we need to go up. This would be going from mass of 50 times temperature change from TF, or from 0 to TF. So I do TF minus 0. CP of liquid water is 4.184. And then I set that equal to negative Q loss like this, so 500 times TF minus 80, and CP of water 4.184, and then solve for TF using algebra. Whenever I personally solve these, I just write one equation to start off with, knowing that on the left side I'm dealing with the 50 grams of ice. This would be it going from negative 10 degrees to 0 degrees Celsius ice. This would be it melting. This would be it water from 0 degrees Celsius to TF. And this would be the 500 grams of water going from 80 to TF. And I just do it as one equation at the start. You want to break it up and do it in the sections and then add it together at the end, whichever is easier for you. You can do it either way. Personally, I just deal with one large equation. I know that on the left side I'm dealing with only the ice, and on the right side I'm going to be dealing with the 500 grams of water that's going from 80. And inside my head I keep track of what the mass will be, what CP I'm on. So make that clearer. Rewriting this equation more easier. If you're doing it all at once, we're doing the negative 10 degrees Celsius to 0 degrees Celsius ice. Maybe it'll be better to write the words above it. Then we're going to be doing the melting. Ice melting. Then we'll be going from 0 degrees Celsius to TF water. That'll be TF minus 0. Final minus initial times 4.184. And that'll be equal to the right side, which would be 80 to TF water. And we do negative on the right side. And it'd be 500, because this is going to be the beaker. And then it would be TF minus 80. And then 4.184 because we're liquid. There it is. I would do the entire equation all at once and then solve algebraically for TF. I know some students are more, they like to break everything out. However, if you do it this way, it's very easy to make a mistake. At least here, you can look over your entire equation. We know that here, all the masses should be 50. We know during ice, CP should be 2.06. HF is 334. And I could have put in here actually 0 minus P negative 10. So let me write it. So our delta T was our final was 0. Our initial was negative 10. So that's equal to a positive 10 right here. Reason why I had 10 here. And because delta T is always TF minus TF minus TI. Final minus initial. So the water began at 80 degrees Celsius, and after adding 50 grams of ice to it that was at negative 10, it cooled off by about 15 degrees, from 80 to about 65. Which way is better? Writing the equation all at once or breaking it up? The long way? So doing the long way? So again, extracting the information and applying the equation and setting up the equation. This is the chemistry portion. Solving for TF is algebra. This whole thing is just the total heat gained by ice cube. While this, excluding the negative, is the heat lost by beaker of water. Any questions? Here's the code word of the day. For this class, 1